Muito fantastico. So, welcome to our wonderful, nice, cool session here. So we could just get the good morning a little bit away here because we want to actually talk a little bit about BIM. When you have any questions, just ask. This is not a problem. It's all easy cruisy. Okay. So when you probably have heard about BIM, what BIM actually is, about this whole acronym about BIM. What is BIM?
For me?
Yeah, or how would you explain it?
So building information modeling.
Yes, very good.
Yeah, brings to light.
So, very good. So we have information and we have modeling together. Yeah. Theoretically, you actually would need to write BIM to the power of 2. Theoretically with the M. This is not because it has to do with building or with architecture. It actually just means theoretically it's modeling and also actually it's management.
I see.
At the end. Good. Let's have a quick look to this where actually BIM comes from, and we actually want to understand what actually BIM is here. If you would explain BIM in a nutshell to somebody, you can actually say that BIM is actually a business process. Sounds a bit weird, but theoretically you can just say BIM, yeah, that's actually a process, and this is actually how we actually do business. So this is basically how is the way how we do business. Itself, there's not so much involved actually. And it actually becomes pretty clear where actually everything comes from. Let's just talk a little bit where actually this whole BIM and everything actually comes from. And it goes back, for instance, to the 70s. And in the 70s, we actually had a major development. Do you know which one?
An earthquake of some sort?
No, we actually had the PC. We actually had the home PC. In the 70s.
I see.
That's great. And later on, we had a couple of milestones around in the 80s. We had a couple of milestones around in the 90s. We had a couple of milestones around 2K, and then there's around 2010. We have some other milestones. So in the 70s, we actually got a home PC available. And I don't know if you still remember, maybe some stuff like this here as an example. You probably wouldn't get Revit to run on this one here, but I found this once on the internet, and I thought this is for the education. It's actually pretty cool to explain it, because from the 70s a whole story actually started where we actually find our pencil obsolete, and we actually go from the pencil actually to the computer. So this is the whole thing what actually happened. Should be a title block. Maybe we can actually also get our nice building down there. So basically, so we go to the computer. And so this whole journey actually started in the 70s because we're always on the way try to get a better tool. We always try to find, have a better way to communicate. The other way is what I would also say is it's not necessarily a business process, but on the other hand, you actually could say that BIM is actually a communication process. And it's the way on how we actually communicate. A communication process. And this, you can say on the other hand that this communication process is actually digital. Has a couple of advantages, which means, for instance, when in the past when we were sharing paper, for instance, that paper was pretty cool, everybody could sketch on it, but as soon as you wanted to copy something, as soon as you tried to identify some data, as soon as you tried to look and to search for something, it was possibly a little bit tricky at this point. So you probably, I don't know, if you have done some drafting in the past, but maybe in the past you maybe remember still some of maybe some of these tools here as an example.
Sure. Mm-hmm.
Yeah, and so in the past we actually used those actually to create actually some just our paper, and from the paper, as mentioned, from the paper we actually go to the computer. So the whole computer, so BIM is everything about the digital technology. So this is all what's actually about, and what we want to do. Okay, cool. So what I just need to tidy a couple of things up here because they just moved and shuffled around. So, but this is not a big issue here. 10. Good. So in the 7 days, basically, we went to the computer, and we know that BIM unfortunately is a bit computer-centric, which means that when we, for instance, have two industries actually trying to balance them on top of each other, you could say we have the IT industry like a ball, and we balance actually the construction industry on top of a ball. We actually find that when you try to balance two balls on top of each other, it's a little bit tricky. And for instance, also what we see here is that some guys are a bit struggling with building information modeling because they don't know about computer. They are not familiar with computers, and this is what makes the biggest problem. So on the one hand, on the downside, unfortunately, we have a little bit a computer literacy. So you need to know a little bit about the IT. So if you don't know about computer, if you can't handle software, if you don't know about hardware, if you don't have any drive, any connection at all to it, you're stuffed. I just tell you straight, forget about it. Go into a different industry, just straight as it is. On the good side, of course, when we deal with computers, when we try to copy something. Also, on the other hand, is when we try to store maybe some data. On the other side, when we, for instance, search something, it's all this is basically around a computer, where the computer actually helps us, where we outsource it. So that's good. And unfortunately, because the IT itself is an own industry, so it's basically an industry on its own. How do you write own? On its own. The industry is actually developing further and further. So you could say the industry doesn't stay as it is, because when you look, for instance, the pencil here, it didn't change over the last 200 years. The pencil still stays. So the pencil up to here on the left-hand side, it could be a picture we just I just took right now from my desk. But when I look, for instance, at the computer, how much did the computer change? Quite a bit more. Good. And so it is also here with the IT industry. So we have a huge change, for instance, there. And this is, for instance, also a bit of the negative parts, that not only that you know about the IT, that you learn it, that you need to keep on the ball with it. And this is also something where people are a little bit struggling with. However, you cannot imagine when the IT changes every day, kind of, and the construction industry actually relies on it. You get actually here a boost of the construction industry, which is basically exponential. Because as more tools in that IT are available, as more the construction industry can actually benefit and profit from. So now we need to understand now just a bit the dimensions where the construction industry benefits and wants to profit from. Hence, when we talk about building information modeling, we have something called like a BIM wheel. Sorry, there's an E missing. So BIM wheel. And with the BIM wheel, we have actually also BIM dimensions, like we have a 2D dimension, we have something like a 3D dimension, we have maybe something like a 4D dimension, we have something like a 5D dimension, we can also say maybe a 6D dimension, and maybe also a 7D dimension. So 7th dimension, 6th dimension sounds all a little bit spicy, but it's actually not too complicated to understand. And the 2D dimension, this is actually what we had a little bit earlier when we go back around the 80s and 90s. Because in the 80s and 90s, we had something called, for instance, CAD. So we had the first CAD development, okay? And this means, for instance, that we got, for instance, 2 points, and within 2 points, AutoCAD could kind of render a line, basically, in between. So we had a point 1, and we had a point 2. later on, also the computer basically could render an arc or maybe a NURBS in between. So we had some absolutely basic and simple geometry. However, it was just actually stored in just some simple lists, and it was just stupid, it was deaf, it was dumb, and but it could help already a lot, as you probably remember.
Mm-hmm.
So in the 90s, we had some other developments, especially everything around Oracle and so on. And the guys actually made a relational database public. So what has now happened with our relational databases around the 90s, that we had some other developments happening, for instance, with ICCAD or also AutoCAD, got some stuff with it. And the CAD drawing wasn't actually stored just in a script in a list anymore. So what they actually did, they actually stored the database. So they actually stored the drawing in tables. And what happened is, once we had a lot of tables, all these tables, as you know, with a relational database, maybe that they are all connected with each other. So all of a sudden, my CAD drawing actually still has actually a point 1 and a point 2, point 1 and a point 2 to read out the geometry. But here we actually started that our geometry became parametric. So in the 80s, we just had geometry.
Mm-hmm.
Then in the 90s, the geometry became parametric. Okay, and then around 2K we see a bit more happening. So point 1. And what does this mean, that this parametric? That we actually get here some relationships between point 1 and point 2. So we have a relationship 1 and a relationship 2. This might be, for instance, the length and the height of it. So when you, for instance, now stay in a room and you look at a wall and you want to see to this wall, I actually want to have this room 1 meter wider. Point 563 from 2506 to 2507. So from the XYZ coordinate to another XYZ coordinate. Now with the parametric, you just actually need to just change relationship 1. And the coordinates, the XYZ coordinates for point 1 and point 2 actually they actually change and they actually update with it. And this is because we have some relationship databases. So as you know, relationship databases, you cannot save them backwards, because as soon as you have a new feature, we actually have new relationships, and with new relationships you get a new revision, a new version. So hence, for instance, with Revit, like with any business database, with any contact address database, you can never save a relationship-based database backwards. It's not possible. It's impossible. And also, there's a little bit, the industry gets used to it, but it's just how computer work. Computer doesn't work different, as you might know. So, good. Good. And so, what happened around 2K? Around 2K, the CPU was a little bit too slow, and what people actually introduced was a little bit of some multi-core processing around 2K. You probably remember maybe a 486 DX2 at DX6 or something similar like this at this time. You actually could buy maybe. Maybe you had also some first Pentium computers and some multiple cores, hyper-threading and all kinds of stuff around this time was basically introduced. So what this was at the time, it actually opened up the door to take the geometry to the parametric and actually add on information to this geometry. So what this means is that let's maybe grab here maybe just another color. Let's see which color actually would pop out here. So that not only that we have basically a geometry which might be maybe a beam, but where does this beam actually come from? We now can actually understand and ask. It actually still comes from a line. And all of a sudden, this line what we have turned actually into a business, because this line all of a sudden became a beam we now understood. Okay, so we have now a beam. Okay, where does this beam come? It comes from a line. But how is it modeled? It's just modeled by a line, and we associate now attributes with this line. We have attributes, parameters. So this could be maybe a beam, this could be a duct, this could be just maybe even a door, maybe, for this. So whatever I have there, I just associate with this line. So with this, we get, for instance, some attributes and also some properties. Some attributes, properties could be costs, could be material, could be anything you actually set up and do with the geometry. So what we actually do here is we model the geometry and we model the information attached to the geometry. And this leads us actually back to a couple of disciplines we were just started to explain. And you can basically say that a little bit in the first disciplines, obviously, they are a little bit geometry driven. So this is a little bit the geometry of what we have. Later on, we find then that we have a couple of other disciplines which are a little bit more on the information side of this. 2D, traditional 2D BIM. So when you would go now, for instance, to our airport, we have here, and you say, okay, you have what? You have a building project. This is pretty good. And what type of BIM project is this? Probably they would tell you, okay, it's a 6D BIM project. So to understand what you then tender for, we actually would need to understand what actually the different dimensions are. So let's start, for instance, here with the second one first. So when you have just a 2D BIM here, you could say it's like we have dynamic blocks with AutoCAD. Dynamic blocks, for instance, with AutoCAD. So what do we do with these dynamic blocks? We have actually a flat CAD, and we have a couple of parameters with these flat CAD blocks, while we actually also can do a data extraction or can hook up AutoCAD with an Excel database or with any other kind of database, and just can read out basically the value. This would basically just 2D BIM, so we make use of dynamic blocks. In the third dimension, we actually do this whole thing, for instance, with Revit, as an example. So we have actually here everything in 3D, and everything is basically parametric for that. So if I want to change something, I can actually, I have to model with my relationships. So I have to do actually not a geometry-based modeling. I actually have to do a relationship-based modeling. So based on my relationships, I have to model the building. And so the whole data entry is a bit different, like to a traditional CAD software, which trips off if somebody starts new with Revit or tries to learn Revit for himself, which is a little bit challenging, I can tell. Because when I started to learn Revit, there were not so many courses around. Good. Or nobody actually told you. Sweet. So we do this whole actually here in 3 dimensions. With the fourth dimension, we get something to do. It's called phasing. So what's the phasing? So we can, for instance, model the building and different construction stages. You probably have heard about Navisworks. And for instance, with Navisworks, we have a timeliner. And what we actually do, we actually simulate actually the site. When we actually build something, when is the foundation being built, and so we do the whole site coordination. So it's also called a little bit the BIM coordination phase. Okay, so this is what we do with 4D. However, we also start already with some first scheduling at this point, because as soon as we have some geometry, we actually can also schedule and throw out a couple of data. The fifth dimension are actually our costs and scheduling. So what does this mean? Because I have manufacturer attached to my geometry, because I have the volume of steel I can calculate from my geometry, the length of my beam I can calculate, I can work out my steel connections, I can work out, for instance, the amount of reinforcing, I can work out the type of door I'm actually using, the part number of my door. I actually can work out and can see in real and lifetime, while I start modeling my building, how the costs actually behave in my building. And so all this is actually then being visualized. You could say between up to 5D, This is a little bit on the possibly more on the construction side, what we have. And now let's leave a little bit the construction side, where we go to the 6th dimension, go to our LEED analysis, or to our green star analysis. What does this mean? So that we actually attach specific information to our geometry, like for instance the R value of the insulation. We have specific electrical resistance. We have specific heat transfer. We have a specific value on how much light actually comes into these windows. Are the windows tinted? The orientation of the building, the location of this building. So what we actually do, we do a solar radiation, we do also lighting analysis, we do a heating and cooling analysis of my building because of how the building is being built and what the information has been attached to. So the whole energy analysis through the lifetime of a building I actually can analyze here. Let's call it the 60. So obviously we want to build green, hence the airport says we do 60 at this point. And all this data actually needs to then be modeled, and hence we need to actually know on how we model the data, when do we model the data, and there's something called out there in the industry which is called a BIM Execution Plan. Called also BEP. Good. With the BIM Execution Plan, we actually organize how much and how far we actually model. Because you can imagine, when we just do 3D BIM, I actually don't need to worry about my time, about my phasing, about my manufacturers. I can just put this tentative or indicative or something into the model, but it does not need to be checked at this point. And for instance, with a BIM execution plan, we discuss, for instance, about the tender process, how we tender, what do we tender for, about the milestones, about the coordination. But obviously also we want to talk a little bit about what hardware we are actually using and also what software we are actually using, that we are all ideally on the same page. Ideally everybody would say works, for instance, with Revit 2016, and we have maybe a central model. So we also, when you have the coordination, we also discuss, for instance, the collaboration as such. Because of the collaboration, we actually also discuss, for instance, the level of development or the level of information. Level of development mainly associate always with geometry. I would say it's actually a little bit more. It's how much effort you actually put into the model. People also discuss the level of information. It's how much information you actually attach to it. And with the LOD, you probably have heard something like 100, like a 200, maybe 300, and maybe 400, and maybe 500 as an example. Some other creative people came up also with the 350 or with the 250. Be creative as much as you like. Only thing is, please do me a favor and define it. Because sometimes people come up with a BIM execution plan, it's just 5 pages long, and they say, no, that's not a BIM execution plan. That's a flyer. That's a BIM execution flyer. It's not a plan. And so what we do is here, for instance, with 1 to 200 is our concept. Then later on, we go a little bit to our design phase. And then, for instance, here we have also our shop drawings we discuss. And then, for instance, we have also our as-built. Some other creative ones, they also go further with an LOD of 600 and further, and 700. I don't know what's more than as-built, but I believe that they probably mean something on the 70, which is for our facility management, is that they actually discuss then the amount of data you attach to your models about the history of the maintenance history. So if you go 7D, you actually also need to plan the whole infrastructure of data to maintain actually the building. When you go from 2D to 60, a lot can actually be achieved through Revit, Navisworks, any type of quantity software you're using, any kind of energy analysis, be it also in the cloud or others. The big gap when it comes to the data is still between 60 and 70, because when it comes to the facility management, everybody has a little bit his homebrew solution. There's some cool stuff out like Ecodemus, like FM Systems and VU, and they have a lot, and also Autodesk offers some operation software, but it's still not that streamlined like the whole development process is. And so the biggest gap is actually here between going from our 2D to 60 to the 70, where a whole data actually needs to be organized. Yeah. And one format here comes into play. It's called maybe COBie. Okay. So let me, for instance, have just a quick look on COBie here. When you look for COBie, you need to type in COBie and BIM, because otherwise you end up with COBie smolders in the search engines. And and here, for instance, you see as an example that COBie actually discusses on how this data actually is being structured. And in the industry, what you currently see is first come, first serve, because there's a huge demand there currently, because all figure out that you actually can do, that you can have a lot of savings doing and working, for instance, and following a BIM process. So, but on the other hand, it needs to be a little bit organized. And so as soon as somebody starts organizing something, basically this kind of this method is being adopted. Good. And but which actually leads us so far that we have, for instance, COBie. We find actually also some Revit templates for COBie, or Revit templates. We actually need to write add a T here, for instance, as an example. And somewhere we find also here maybe toolkit, for instance, for Revit as an example. There are a couple of more blocks out there, and so in this case, just go for it and have fun with it as an example. As an example. So that's good. A2K, do you know this company?
I've heard
about it. Yeah. Good. So then we have here, for instance, and this is where a lot of the data actually needs to be restructured. Also, what we, for instance, find here some other file formats at IFC. Also in the BIM Execution Plan, they are talking, for instance, about the exchange format of the file. So it's also how the file exchange is, for instance, happening. Some people specify in IFC, what I do not support because it's not ideal. Because when I write an IFC file, it's a flat database, while the Revit is really a real database, what we have. Somewhere I can actually quickly give you a picture on how this actually looks like. I have an X drive from an Access database, because you can actually push out Revit to an Access database. That was in 2014. So this, for instance, how our Revit database actually looks like. And so we see here on the left-hand side a lot of tables, and all these tables here, for instance, doors, door types, and so on. We also find them obviously here the same way. And we see, for instance, with the foreign K and how they actually connected here. These are all our connections actually in the bag. It's pretty interesting, pretty amazing. I hope that nobody never asks me to sort something out here, because I would say, no, forget about it, start remodeling, building. So Revit actually becomes a visual database model, or it's just database entry software. It's a front end to a database entry. For database entry. While actually Revit is the only software which actually looks at all 6 disciplines, which is, for instance, that we have the architecture, that we have also, for instance, the structure, that we have also the mechanical guys, then we have the sparkies together, the plumbers, and also, for instance, then the coordination. So this is, for instance, where we then click into Revit, have all 6 disciplines. These 6 disciplines have nothing to do with our disciplines, what we do here. These are the BIM dimensions, actually. Okay, because
Okay.
you also mentioned this sometimes discipline, but good. So this is what we have. So with the BIM execution plan, that's the biggest key. Also, when it comes to the BIM execution plan, and it comes to the file exchange. Also here, a lot of data needs to be converted. So also here we have a lot of data conversions. Because as soon as we deal also with the coordinate, as soon as we want to coordinate data, and there are a lot of data, sometimes data needs to be converted because sometimes because of political reason we accept some other software. Ideally, everybody's on the same software, obviously, as we know. Good.
Mm-hmm.
So why and how do people actually came up with this whole idea, and why actually this whole development? Obviously, what we see is that we got different construction phases. So when we have, for instance, here the construction, for instance, our 1D to 60, and we get our FM side, our 7D, we find in the construction that we have maybe 4 different phases, we can say. We have here, for instance, the conceptual, and we have, for instance, also the design phase. Then we have maybe also our shop drawings, and then we have, for instance, also our construction. Good. Over the time, people figured out that over the time you actually have less influence on the change. So basically the influence on change. But when you want to change something, it becomes more costly over the time. Makes also sense, or? So basically the dollar of a change. There are a couple of clever guys like McLeamy who figured this out. Some others figured this out 20 years prior to him, called somebody, one of the profs called Davis, I think. So because Davis was a little bit more IT-centric, and what we, for instance, remember that actually our BIM process is actually relying on the IT process. So how we actually organize and write applications using, for instance, Scrum, Unified Process, Kanban, all these kinds of business methods on developing applications, we can actually also apply them to our construction methodology to organize actually the development of our building. So like we, for instance, have our app development. So as such, the same methods we can actually also use for our building development. Also here, a lot of data needs to be converted and needs to be transformed and actually needs to be cared for at this point. So same thing, for instance, the same method we can actually use, for instance, here Kanban. Many probably offices we have a little bit of a Kanban. Just help yourself.
So what I can't read that top one.
Sorry, this one, the brown one.
Yeah.
I just did Kanban.
Oh, yeah, okay. Sure.
Or a Scrum or a unified process or something like this.
Mm-hmm.
So if you just have some agile development in our building design, and it's the same thing what we, for instance, have also over the time that we have here kind of an agile building development actually. But there's the same patterns, the same principles. Like we develop, for instance, applications also applies to the development of a building. And you know, for instance, when you develop data that you have a lot of UML scriptors, you have a lot of other planning software actually with it, which actually would help to organize actually this whole collaboration and also for this data. All this data, it actually needs to be cared for. Good. Most of the changes, where do you think most of the changes are currently happening in the industry? Are they in the concept phase or in the shop drawing or in the construction phase?
Well, I would say, yeah, where I think they're happening is that when you get to the construction phase is probably where the real world comes in, right. And you see that your plans aren't working.
Absolutely right, because it's the first time when everything comes together. It's the first time when the structural engineer and the mechanical engineer, the electrical engineer, and the architect actually figure out all our plans actually don't work. And
Yeah.
so hence we actually can say that building information modeling is, on the other hand, actually a communication process as well. And where communication is, a lot of data flows, a lot of data needs to be converted.
Is there some quantification around that the changes actually do happen in that part of the construction process? Because I think this is probably the big sell for people, is convincing them that, you know, actually there's a lot of, you guys are wasting a lot of time because there's a lot of changing going on. And I think you'll get some, the blowback that I sort of feel is that the people who are been doing this for the last 20 years and they don't really think or understand about the amount of changes that happen in that part.
That's right, yes. Absolutely right. There is. You're absolutely right, and there is. What I sometimes see is that many companies actually don't know what they actually do.
Yeah.
Because they don't have a controlling in place. They have maybe heard a little bit about my KPIs. A balanced scorecard is a big buzzword as well. And they have, but they actually don't have any controlling methodologies and no controlling awareness in place. So every job, they're always over budget. With every job, they're always late. With every job, they're always going to court. With every job, it's a pain. With every job, they don't know what they do. With every job, they have they issue the drawings 3 days prior the deadline, while they actually know already 3 months about this job. Yes, this is kind of people, they are not reviewing themselves, and companies, they don't add transparency. And this is, for instance, also one of the fruit, what we have, for instance, with our BIM, that we actually talk and we actually want to expose actually how good you know actually your industry and how good you actually know your business. So with BIM, we actually want to expose, and we are going also with our BIM execution plan, for instance, after transparency in all directions. Also, because of the exposure and to the transparency, if you know your business, we also go after the legal side, for instance. We deal with this as well. And for instance, at the end, you could actually say that a BIM execution plan is nothing else like an external CAD procedures. Companies, they have maybe their internal CAD procedures, but a BIM execution plan is like an external CAD procedure. Let's say maybe BIM procedure, where we actually write down how we actually coordinate. And very often also here the political devil kind of kicks in. We actually would need to cast out, is where they say, okay, I actually can't write it down because I want to leave the door open in case somebody else want to change something. No, you must write it down, because if it's not streamlined, if it is not structured, the structure is falling apart. And this is where, for instance, many then try to have a little bit of open or social BIM, or a kind of, which is, don't understand me wrong, it's good that we have open data we want to share, and also when we socialize that we collaborate. This is good, but we don't have want to have a business process in place which just everybody does whatever he always wants to think is right. So we need to see the whole collaboration like an orchestra. If you imagine an orchestra where every violin, every cello, every piano, all the brass, everybody's playing something different, it's a chaos. And this is what we currently have in our construction industry, or still. And this is why we want to bring it more to the front. So hence also our software actually needs to cope with this, because we obviously have more changes in the conceptual rather than on the on-site. On-site, we probably have changes, but we have a few costly changes. And in the conceptual phase, we actually can figure out a lot how we actually want to build it, that we actually get it right for the future. Because if so, if you want to get it right, we actually have a pretty good benefit, because some clever universities figured out they have about 20 to 30% during it. I was, for instance, recently talking to somebody who mentioned they have more coordination work up front, and all of a sudden the whole design process costs, and the whole construction process costs 20 to 30% more. This is wrong. They have the more cost of the coordination because they have no BIM execution plan, no structured BIM execution plan, and nobody's following a BIM execution plan. If everybody would like you would see it like in a military or like in an army. If we would have a structured approach where everybody is part of, we have gigantic savings.
Mm.
And this just needs to be structured, and sometimes, yeah, you just need to obey. But nowadays, everybody says, no, I'm not obeying because I'm the champ. And where we actually face with BIM, some more spiritual issues, some soul issues, some hearty issues. Basically, this is what we actually face around, unfortunately, which makes it a little bit tricky sometimes to implement it because the management, they are more protecting the chair rather than actually supporting it, unfortunately.
Yep.
Even when it comes, for instance, even when it comes, for instance, to the savings, they actually see around because as soon as you have the collaboration structured, another key, then you're actually on the good side. Another key, for instance, is that in the traditional, we have something called Bitbuilt, which means that, for instance, let's say the architect is going to a structural engineer, and then the architect figures out, oh, we actually need to have maybe a mechanical as well, and later on we go maybe to a plumbing engineer. And what else do we need? Maybe what about a Sparky? Yeah, the Sparky comes a little bit earlier on board. So we have the electrical discipline, for instance, as well. Somehow a little bit later we figure out, oh, we actually want to build it. Oh, this might be maybe also a cool idea if you want to build it, and then later the construction guy comes on site. So the problem is now when the structural engineer has a change, he actually is engaged by the architect, gets back by the architect. The architect obviously answers the structural engineer, but very often he actually misses out the mechanical and the electrical engineer. So when they actually go back to the architecture actually just answers his plans and actually misses and leaves out the structural engineer. And then all what you get is actually that you have a lot of revised and old plans actually everybody's always working on. Ideally, we have a central storage and a central coordination of our data. And this is, for instance, what happened here in 2010 now, a little bit later on, that we actually go with our model actually towards the cloud, where actually everybody can share the data. So we get a lot of cloud application. We just buy in software as a service when we need it for our coordination, whoever is looking after the coordination. So we see how the industry is actually changing. And so we actually store then our data in the cloud, be it, for instance, through an A360 service or through anything else. Good. And with the traditional Bitbuilt, it's sometimes a little bit tricky, but even if you do a traditional Bitbuilt and you are disciplined, it's actually, you can also still change and target your savings. I believe that a lot of these, and what I believe it because I see it, that a lot of these coordinations people have are just because they don't want to make the decision in the front, they want to keep it open for later. But we actually want to have the decision in the front, we want to have the decision now in our design phase, where we actually want to, in our conceptual phase, where we want to make the decision because of the responsibility. And this is, for instance, where also BIM Execution Plan, for instance, kicks in, where it's actually where BIM Execution Plan actually talks about the responsibilities. This, for instance, ends up by the end as a structural engineer or an electrical engineer or a plumbing engineer or an architect. You are being paid what you actually tender for. So I'm tendering for the sizing of the columns, and this is the amount of risk you take, and based on the risk, you're basically being paid, you see, for instance, for the risk. And it's also, for instance, the risk management, what we have in the BIM execution plan. And or do you also take the risk or the responsibility to model it that way how you would build it? For instance, in Revit, you model it how you would build it, which leads a little bit to another challenge because a lot of young guys, they know about computer, but they don't know about construction methodology. Some of the old guys, they know about construction methodology, but they don't know how to switch on a computer. So there is a little bit of an age gap. in between. Best thing is you partner them up. When we have, for instance, here then our risk, then later on when we have our digital prototype, we actually can write also digital producer statement about the digital prototype of a building, then a contractor actually can also build on. But ideally, you actually have the contractor a little bit earlier on board, and this is something what you find in the industry is called here IPD, Integrated Project Delivery, where we have, for instance, our architect, also, for instance, when he starts the project a little bit earlier, then also our structural engineer, and also our mechanical engineer. We have also our plumbing engineer. Somewhere we have also our Sparky, maybe again. Add them up, and then we have also, for instance, our contractor on board. So because as soon as it comes to a change, it's communicated on a central model across all.
Mm-hmm.
And so here we see, for instance, that's a communication process. It's a business process on how we actually do business. And so everybody's actually involved, and actually everybody can chip in, ideally. But also here, then people say, I can't really share my data, but I have, for instance, the authority of my data, or I have the intellectual property of my data. Now, when we come, for instance, here, also, ideally, to our BIM, what we model is part of whoever owns the building, theoretically, and for instance also is, for instance, sharing equals caring. Because as soon when I have here a me attitude, for instance, have a me attitude, this costs a lot of money and has a lot of errors. So we want to share actually our data, but with our partners for transparency and for actually to check if we are actually right on this, if it actually works for that. And that's why we actually must make decisions. And if you don't make the decisions, it costs money, just as it is. You can't change it. Good. We have got about in the facility management is, for instance, $1 to $4 spent. So for every $1 you spend in the construction industry, you spend about $4 in the facility management. And some clever universities figured out that they can achieve about 30 to 40% savings in the facility management later.
That's huge. Hey,
hey
Florian,
imagine
can we take this?
$3 million building, and we have maybe a $40 million facility for the facility management. We spend about $40 million, and you now want to understand here about 30 to 40%.
Yeah,
that's actually a lot.
That's a lot of money.
So what we, for instance, have seen now is here that when you quickly scroll down is that we get a $1 into $4, which when we have, for instance, a $10 million building, a $40 million facility cost of facility management, we get about 30 to 40% savings, so that's huge. And all it's actually about the data and the lifetime actually of the data we're actually dealing with. And so even when we have maybe a couple of reconstruction, a couple of alterations actually across the lifetime, we somehow need to have a plan. We somehow need to have some data we actually can work with that we know. And now, currently, nothing is actually available for many buildings. Everybody just tinkers and builds just somehow for the next day, just to get the job somehow done and then moves on, because nobody actually oversees the whole lifetime, the whole span of information and data. And this doesn't mean that it's bound to the technology, because data will always be around, geometry will always be around, will never change. But so we have maybe also new businesses coming up, for instance, that look after the data. For instance, could be the council or could be others, doesn't matter. But important is actually that we try to make the decision. If you, BIM actually lives from one thing, and this is that you are proactive. And if you're not proactive, it actually works out against you. Because we're currently in a process where we are not proactive, where we think that politically right actually means, or politically correct means to put the head into the sand, rather actually to sort it out and to keep everyone at the door open, because we think positive.
Yeah.
So, good. We need to be proactive, then we got a lot of savings. Savings don't fill the pocket, but fill the pocket faster. and this is also what we actually would need to consider. And to be honest, there can't be enough financial crashes on this planet to push it.
Mm-hmm.
Because they figure out, okay, we still need to have the demand, but all of a sudden we are constrained by less finances. We need to have insurance companies, they need to be clear of the risk they take. Banks, they need to know about the money they actually lend. They are after transparency, and this is what actually BIM is actually after transparency. As soon as you try to hide something, it works out against you, unfortunately. And that's why it scares a lot of people in the industry, because a lot of people actually don't know what they do, because they actually never looked at their business for the last 30 years, and so can we actually do this better?
Yeah.
And that's the improvement process we had along for the last whatever years, that when we, for instance, go back in the 70s, we said, hey, can we actually use the computer just to communicate better and actually to do a better business, just to make our life a little bit easier? And well, we're balancing two balls on top of each other, as we have seen. And well, we need to be a little bit of a computer whiz, unfortunately, for this. And yeah, we actually need to want to bring it into the front. So this is what's actually about BIM, what when we do, for instance, with the data. A couple of cool websites when it comes, for instance. For instance, one of them is, for instance, the BIM Hub. I think as an example, let's see if it comes up here. Yeah, grabbed it. For instance, here's a website where you can get some nice, cool stories. And you see, for instance, a lot of companies are here advertising as well, and a lot of guys are actually apart from this. For instance, this is one of this. Another one, for instance, when it comes to the whole collaboration, you find, for instance, anzrs.org as an example. Australia, New Zealand Revit standards, for instance, for us. You can just here log on, become free member, and download the checklist. It's all about the collaboration, how we create, for instance, the families. When it comes to, again, to the facility management, we had, for instance, here also our Kobe and BIM as an example, as a task group, for instance, here coming up. Another one is, for instance, also Building Smart Alliance, where we have talked a little bit about IFC files and Industry Foundation class files, actually from Autodesk for 1994, I think, around this. And they actually organize this. So there's a lot around here, for instance, when it comes to the facility management, and it also comes here on how you want to share and deliver this data. For instance, also the format from the IFC file, how you structure it. If you find support all over the place. For instance, when you go just to our apps.autodesk.com as an example, we find here a lot of this as well. When it comes up after a while, yep, for instance, when you go, for instance, here just to Revit as an example, and then we search some app, and then we have here, for instance, IFC, and let's look, for instance, if we have some, also here, for instance, we see a lot of IFC exporters and other stuff, for instance, around here for our files, for instance, dealing and working with it. We have also a lot of import and export of data, be it, for instance, you may have heard about BIMlink, for instance, about that. Just to mention a view, for instance, here, ideate our BIMlink, where we, for instance, import and export some data, which is pretty cool. So there's a lot of stuff that's actually around here, and it's about the geometry in the data. So coming back then to our list here, we get, for instance, when we design with Revit, we get actually two different parts. We get a project part. So we have a Revit project, which is, for instance, an RVT file. And then we get a family. Everything within Revit is actually a family. But we get three different types of families. That's a system family. I may also call another system family a hybrid family, and we get a user family. And this is actually being organized based on how you actually change the geometry and data within within this project. So RVT, once a Revit file, we have also coming here this RVT from an RTE, which is a project template, so which is here a template. And then we have also an RFT, Revit family template with this. While we actually get here different types of families. We have, for instance, a system family. We call it another one. I may call it maybe a hybrid family, which is actually a system family. I may explain it in a second. And let's call it maybe a user family. The user family can be in two ways. You can make this and organize this maybe in 3D and in 2D. Once in 2D, it actually can also organize and drive a system family in form, for instance, annotations. That we have annotations, that we have also maybe a slab, edge. This might be maybe a profile or something like this. Or maybe that we have this also in stairs. Also with stairs we get also maybe handrails, something like this. 3D we have, for instance, something like a column. Because if you have a UB or if you have a UC column, it doesn't change. Only the length changes. We have, for instance, a beam. We have, for instance, a door. We have, for instance, a window as an example, because the type of the window doesn't change. So the geometry is once being modeled as screw, and this is based on what the manufacturer actually offers. On the system side, we actually have something like walls. We set up something like ceilings. We set up something like, for instance, roofs. We have something like floors. Why? Because we have always the same type of wall, might be 190 block wall, for instance, in our building. But the layout and the shape changes a lot. So what you actually could say that these actually work against each, where we have, for instance, the shape changes, while actually in our family, we have actually where our type actually changes. And also here, for instance, when it comes into our system, that the system is commonly in the project is sketched. So sorry, I actually wanted to write sketched. Sketched in the project. And while we actually have an own like a block editor, in big hyphens, like a block editor where we actually create and set up this family. So these are, for instance, these two types of systems, and they actually work well, but all of them, they actually have the data around like a manufacturer. They have different types of information, and the information is actually stored quickly in a parameter matrix, commonly, you could actually say. And this is, for instance, that we have some instance parameter, and then we have some type parameter. So the type parameter is actually global, and this is throughout the whole project again. The instance parameter is just basically local, and whatever has been selected is the instance parameter. And then we organize them through a global parameter. Then we have a project parameter. Then after the project parameter, we have a shared parameter. And then we have also a family parameter. And this can be, for instance, that a project parameter can be type, for instance, a shared parameter could be type, for instance, also a family parameter could be type, for instance, where we actually get here a little bit a matrix of parameter together. And this is how the whole information is actually stored to the geometry. So again, we have, for instance, here our geometry, and then we have here just our data attached to it. And they love and like each other because Revit is all about relationship, okay? And so this basically be married together. Now the other question is, where's our traditional DWG file? DWG files can also store some relationship databases, and if nothing is lost, all what we do is with the DWG, we serve, for instance, our geometry. We just can, for instance, link it, or we can also just import it. Doesn't matter. same as this point. For that, when you have, for instance, data, we have some other files we are, for instance, dealing with, be it, for instance, an Excel file, be it a CSV, be it a text file. This is what we deal with our data, as an example. And they're all together, they become just one project. And this is in our RVT, or also in our user family, which supports our Revit project when it comes to the files, as an example. So this was our first hour about BIM and file sizes and everything. Any questions from your side so far?